Good morning everyone, my name is Davide Salvi and here I present our work named A Semantic Approach to Detecting Deepfakes via Emotional Inconsistencies, derived from the collaboration between the University of Drexel in Philadelphia and the Politecnico di Milano in Italy. We are all aware that deepfakes are possibly the biggest challenge that the forensic community faces today. The need for techniques that automatically recognize deepfakes is crucial, so that researchers are heavily focusing on this aspect. In state-of-the-art, there are techniques that detect deepfakes based on semantic inconsistencies, like partial glasses or wrong lip movement. In this work, we present a multimodal detector that discriminates between authentic and counterfeit material using a high-level feature such as emotion. In particular, we show that deepfakes fail to reproduce emotion both within and between modalities. Here is the proposed approach, divided into three main steps. Starting from raw data, we extract low-level descriptors which are used to predict the emotion in the video under analysis. The predictions are then fed into a classifier that detects whether the input is authentic or not. In the first step, low-level descriptors are extracted separately from raw audio and video, using toolkits that are well established in state-of-the-art. Then, emotion classification can be performed based on different approaches. We can consider discrete classes such as happy and sad, or a continuous spectrum of two variables, called valence and arousal, where valence represents positivity or negativity of the emotion, and arousal represents excitement or calmness. We choose to adopt this continuous representation since it lets us uncover subtle inconsistencies. So, in the second step of the pipeline, what we do is to build an LSTM-based network that takes as input the LLDs and predicts the subject emotion in the continuous space, considering the audio and video tracks separately from each other. The graph here shows the valence and arousal values predicted from the audio tracks of a subset of the DFDC dataset. This shows that real and fake audios are easy to distinguish, and that real audio is hard to imitate. For this reason, audible emotion is a strong feature that we can use to discriminate videos. On the other hand, we can say the same for visual emotions. Here we can see that fake videos are harder to distinguish from real ones. We believe that this is because our predictions are based on facial landmarks, which is the exact feature set that is being manipulated to generate deepfake materials. This is evident even if we look at the evolution of emotion over time in the videos. Here we can see the comparison between the emotion evolution over time in an authentic video and its fake counterpart. While the visual emotion are properly aligned, the difference in audio is noticeable. In the third and last step of our pipeline, we build an LSTM classifier, and we train it to differentiate between real and fake videos based on their emotional evolution. Our results are very promising. We obtain an accuracy of 96% on video-only emotion features and 99% accuracy on audio-only emotion features. In addition to this, when we combine the two modalities, we reach an accuracy of 99.5% on the DFDC dataset. To summarize, in this work we introduce a multimodal deepfake detector, proposed an emotion-based semantic approach, and achieved 99.5% detection accuracy on the DFDC dataset. In future, we intend to generalize the method to other deepfake datasets and modify the emotion classification method we considered. This research was possible thanks to the support of DARPA and AFRL, which we want to acknowledge. Thank you for your attention. Here you can find all our references. Do not hesitate to contact us with any question.